Hey everyone, in today's video we are diving into my load balancer setup built using HAProxy and Keepalived. This runs on my Proxmox DNS nodes B100U002, B100U003 and B100U004. Here you're seeing the Keepalived architecture. So here I have my 3 Proxmox nodes, each one running a Keepalived service. Here I'm displaying just one virtual IP address. So Keepalived assigns this virtual IP address to one of 3 HAProxy services running on those nodes. And HAProxy then in turn load balances backend services like Grafana, like InfluxDB, like Prometheus and Loki and so on. HAProxy as a load balancer operates on both OSI layer 4, TCP, and layer 7, HTTP, TLS, and I will be using it as a Kubernetes ingress controller as well. That means it supports both TLS termination, where traffic is decrypted at the load balancer, and TLS pass-through, where encrypted traffic is passed directly to the backend. It handles both stateful and stateless connections, which is critical for services like Prometheus and InfluxDB. Right now I'm load balancing several key monitoring services, Grafana as the front-end, InfluxDB, Prometheus and Loki as backends. The configuration file HAProxy.ch is identical across all nodes. It includes default global settings plus specific overrides per service. Grafana is set up with layer 7 TLS termination, then re-encrypted to the backend. This allows me to reuse front-end certificates across all monitoring services. InfluxDB and Prometheus are stateful, so I use TLS termination, re-encryption and cookie-based stickiness to maintain session state. Loki could run on layer 4 with TLS pass-through, but I've configured it with TLS termination, again to support shared SSL certs across services. There's also a layer 4 section for Kubernetes, currently commented out. To make all 3 HAProxy instances and the different backend services accessible through individual virtual IPs, I use Keepalived. Keepalived runs on each HAProxy node and manages the VIP assignment and failover. Each Keepalived instance participates in a leader election. Whoever becomes the leader takes ownership of a virtual IP. If the leader goes down, another node takes over automatically, ensuring zero service disruption. Keepalived uses bash scripts to probe services. For example, for Prometheus on port 9090, the script uses curl to verify it's accessible and that this instance is the leader. If the service fails and this node isn't the current leader, it triggers a VIP takeover. The virtual IP address 10.1.10.109 resolves to Prometheus.in.hcinfotech.ch, the main access point for Prometheus. Keepalived uses a config file keepalived.conf. This config file is also identical across all nodes. Let's look at the Grafana stanza. It starts up in backup mode. It's bound to the ETH0 interface, assigned a virtual router ID and priority 100, tied to VIP 10.1.10.102, and uses track script check API server Grafana. The script runs every 3 seconds and will trigger a takeover if a VIP becomes unreachable. What about split brain? Technically, a split brain condition is possible in any HA setup. But in my case, it's not a problem, since these monitoring services are strictly read-only. In addition, Keepalived relies on a quorum between odd number of instances, in my case 3. If a quorum can't be reached because there are not enough voting members, then there will not be a VIP takeover and the VIP will not be available. Let's go through some hands-on demos and testing of our HAProxy and Keepalived setup. In my tmux session, I've opened 2 windows. One is dedicated to the load balancer nodes, B100U002, B100U003 and B100U004. The other to the monitoring nodes B100U1, B100U2 and B100U3. Let me start here some watch windows so that we can monitor the virtual IP addresses. As you can see, all the virtual IP addresses are currently associated with node B100U002. In the browser, I'm accessing the Grafana dashboard via the fully qualified hostname in.hcinfotech.ch. This hostname resolves to a virtual IP 10.1.10.102, which we've already discussed earlier in the presentation. Hostname Prometheus resolves to VIP 10.1.10.109 and is used in dashboards Node Exporter and PostgreSQL. Hostname Loki resolves to VIP 10.1.10.110 and is used in Explorer logs. The traffic to this dashboard is routed through the HAProxy instances, and as you can see, the dashboards backed by InfluxDB, Prometheus and Loki are all functioning as expected. Let's simulate a failover scenario. Currently all my virtual IP addresses are assigned to B100U002. I will be stopping Keepalived on that node to trigger a failover. As you can see, all those VIPs disappeared immediately off that node and reappeared on node B100U004. I'm restarting Keepalived once again to achieve quorum. Without quorum, a failover will not work. Let's now simulate a complete node failover. We'll be stopping Keepalived and HAProxy together. Once again, as soon as the services is stopped, all these IP addresses went back to another node immediately. It's time to B100 U002. Even with both services stopped, the dashboards should be working as expected, thanks to redundancy and load balancing. So once again, I need to restart the services again to keep quorum. Finally, I'll simulate failures of the monitoring backend nodes. I am shutting down B100 U11. Okay. Now let's test monitoring once again. Okay, so far everything is working. I will pause here to wait till that node comes back up, then I can fail over a couple more. That node should be up by now. I will be shutting down U12. And here once again everything is working. I'm waiting for this node to come up again, and then we can shut down node number 3. So this node is back up. And I'm shutting down node number 3. And once again, monitoring is working. So despite all those nodes failures, monitoring remains available, demonstrating effective redundancy across the HAProxy and Keepalived layers. So that's a full overview of my HAProxy and Keepalived load balancing setup running across Proxmox with TLS termination, VIP failover and service probes. If you have questions, want to know more about my Prometheus stack, or need help designing your own setup, drop a comment below. Thanks for watching. Don't forget to like, subscribe and hit the bell so you don't miss future home lab content. See you in the next one.